Hello, today we're going to be working on some integrals. This one is the integral of 1 to 6 of root x minus 2 dx. So we can break this into two separate integrals. So we're going to have one integral that is the root x and another one that is just 2. And of course the 2 will just be a coefficient, so we don't even need to write that inside the integral. So now when we integrate both of these functions, root x is easier to integrate if we rewrite it as 1/2. And the integral of x to the 1/2 will be x to the 1/2 plus 1 over 1/2 plus 1. And that is going to be evaluated from 1 to 6. Now the integral of 2 is just 2x, and again that's going to be evaluated from 1 to 6. So when we simplify our exponent and our fraction here, we have x to the 3/2 over 3/2 from 1 to 6 minus 2x from 1 to 6. So we want to rewrite this compound fraction as a simpler fraction, so we're just going to multiply it by the reciprocal, 2/3. And so we have 2/3 times 6 to the 3/2 minus 2/3 times 1 to the 3/2. And that's going to be the first set that we have to solve. And the second part is 2 times 6 minus 2 times 1, which is 12 minus 2, or 10. So if we factor the 2/3 out of here and apply the square root to both of these, we will have 2/3 times the 6 times the square root of 6 minus 2/3 minus 10. Two-thirds times 6 is 4. And 10 is equal to 30 over 3. This allows us to combine our fractions of thirds. So now we have 4 root 6 minus 32 over 3. The next problem we're looking at is a physics application problem. In this problem, we have a velocity function, and we want to determine the distance traveled. So in this case, we can use the integral of the velocity function, evaluated from the time that we want to find the distance traveled over. So we end up with the integral from 0 to 6 of 4t minus 3, which is our velocity function. So again, we can break this up into two separate integrals. So we have one integral that is 4t and another one that is 3. And again, we can take our coefficients out of the integrals to make it easier to solve. So the integral of t is t squared over 2. And the integral of 1 is t. So we end up with 4t squared over 2 minus 3t, all evaluated from 0 to 6. So now we plug in our limits of integration. We have 2 times 6 squared minus 2 times 0 squared minus 3 times 6 minus 3 times 0. So 6 squared is 36. 0 squared is 0. 2 times 36 is 72. And 3 times 6 is 18. 72 minus 18 is 54. And that is your final answer. And the units are going to be in meters. The next question is about a population increasing. And so the population is growing at a rate of 13 plus 51t. So that is going to be p prime. And so if we want to find p, we can evaluate that integral from 4 to 10. Again, we split the integrals up into two pieces. So we have 13 integral dt plus 51 integral of t dt, evaluated from 4 to 10. When we solve these integrals, we get 13t plus 51t squared over 2 from 10 to 4. Thirteen times 10 minus 13 times 4 plus 51 times 10 squared over 2 minus 51 times 4 squared over 2. Thirteen times 10 is 130. 13 times 4 is 52. Ten squared is 100, and 4 squared is 16. Now the rest is just following out the algebra, and there is one mistake here. 130 minus 52 is 78, not 88. So our final answer will be off by 10. I will correct it in a moment though.